Hey everybody, it's Mrs. Groom. It's time to work on our curriculum notebook. We are going to be doing 1.8 primary productivity. So go ahead and get your notebook and open to the table of contents, and you'll see that we're going to be working on pages 16 and 17. So go ahead and open your notebook to page 16 and 17. What you'll be learning in this lesson, the learning target for primary productivity is to explain how solar energy is acquired and transferred by living organisms. So you will learn that solar energy is acquired by photosynthesis. The primary productivity measures the amount of carbon taken in by photosynthesis, and that aquatic photosynthesizers can use different colors of visible light. So on page 17, this is all that you're going to have to write down. So kind of plan accordingly for your space, but I'm going to go over it one set at a time. So you definitely want to write down everything that you see, and if you hear anything else that I say that might be helpful, you can go ahead and do that as well. All right, so let's talk about photosynthesis. Photosynthesis is what captures sun's energy, CO2 plus H2O, with sun's energy is what creates C6H12O6 plus O2. So carbon dioxide and water creates glucose and oxygen with the help of solar energy. So photosynthesizers are the ones who are responsible for capturing and acquiring the energy to be used on the earth. Cellular respiration is kind of the opposite of photosynthesis. This is when all organisms break down glucose in order to get energy, and when they do that, they release carbon dioxide and water. And so this is one way that carbon is returned back to the atmosphere. So we're going to be talking about primary productivity, and let's start off with gross primary productivity. Gross primary productivity is the total amount of carbon captured by photosynthesis. We could be looking at a specific organism. We could be looking at an entire ecosystem. We could be looking at an entire biome. The total amount of carbon captured is going to show how productive that ecosystem is, how much photosynthesis is occurring. Think about when you have a paycheck and your gross income is the total amount at the top that you are supposed to get, but you end up actually not coming out with the gross, you end up coming out with net income. And so this same thing happens for organisms. Net primary productivity is the actual amount of photosynthesis and the actual amount of carbon that has been captured, because you have to take into account the fact that cellular respiration occurs. And because of cellular respiration, some of the carbon is broken down in order to get energy. So not all of it is kept within the organism or within the ecosystem. So NPP is the net carbon capture. That would be photosynthesis minus cellular respiration. Units for both GPP and NPP are grams or kilograms of carbon per meter squared per year. The net primary productivity is usually 25 to 50% of the GPP. So losing half to more than half of your actual amount of carbon that's going to be able to be moved on to the next level. The higher the NPP in an ecosystem, the more lush it will be, which means there's more life that can be supported. It's more biodiverse. And if you look at the diagram right there, it says NPP equals GPP minus R. That is an important equation that you want to write down. Net primary productivity equals gross primary productivity minus R, which is the amount of carbon loss in respiration. Finally, when we talk about primary productivity, we have to talk about visible light, because the light is coming from the sun, and that's where the solar energy is coming from. Now, photosynthesizers absorb visible light on the visible light spectrum. Most red light, though, is absorbed in the upper 1 meter of water, so that's not very deep. So those organisms that can do photosynthesis that are at the very top tend to absorb that red light. Now, deeper down into the ocean, only blue light can get that far. And that can go deeper than 100 meters in the clearest of waters. So you would imagine that organisms that are deeper into the water, into aquatic ecosystems, will be absorbing probably the blue light rather than the red light in order to do their photosynthesis. So photosynthesizers in aquatic ecosystems have adapted mechanisms based on where they are in depth in the water and what type of visible light they're getting. And that is primary productivity. Okay, so switch over to page 16. Right next door, you're going to copy this NPP graph below onto this page, and then you're going to include each ecosystem in this order. So what I'm going to do first is I'm going to show you my setup, and I want you to set it up just exactly like I'm going to show you, and then we'll fill in the actual data for the primary productivity of each biome, and then we'll look at it all together. Okay, on page 16, here is the graph I want you to set up. The title is Average NPP of Some of Earth's Ecosystems. On the y-axis, you're going to have the names of the different ecosystems in this order. On the x-axis should be the average NPP measured in grams of carbon per meter squared per year, and it's going to go by 500. So 500, 1,000, 1,500, 2,000, 2,500. So go ahead and set this up. Pause the video, set this graph up, and then we will look at the different data points. Okay, the top 6 ecosystems are terrestrial ecosystems, so I'm going to use green to show those. And what you'll notice is that there's some big differences in these. The desert has only 100, the average of 100 NPP. So just put a little bar right there. The boreal forest, also known as the taiga, has 750. So that's going to be about halfway between that. Okay, the savanna has almost 1,000, so we'll say about 900. And of course I put it in the wrong place. So what I'm going to do is I'm going to write them down. I'll go ahead and fill this in, write them down so you can fill it in. Okay, so here we have the terrestrial ecosystems and the numbers that correspond with them. You can see that the desert and the tundra have the lowest amount of net primary productivity. Tropical rainforest has the most. Okay, so now I'm going to go ahead and write in the aquatic and give you time to fill those in. Okay, here are the aquatic ecosystems. Swamps and marshes, 2,000 NPP. Coral reefs, 2,500 NPP. Estuary, 1,300 NPP. Lakes and rivers, 300 NPP. Open ocean, 50 NPP. And upwelling zones, 500 NPP. So you can see here that coral reefs and swamps and marshes have much higher primary productivity, which means they're going to have more life, more biodiversity. So in this lesson, you learned about primary productivity. The learning target was to explain how solar energy is acquired and transferred by living organisms. You learned that solar energy is acquired by photosynthesis. Primary productivity measures the amount of carbon taken in by photosynthesis, and that GPP, or gross primary productivity, minus cellular respiration is going to equal the net primary productivity. Higher NPP results in more life, more biodiversity, and that aquatic photosynthesizers can use different colors of visible light in order to do photosynthesis. Good job.